My name is Joshua Alley, and I did the physics of pool, or two cue balls hitting each other. And the problem was the effect of a cue ball with a certain initial velocity hitting the stationary numbered ball. And the main result was, although this collision appears to be difficult to simulate, it behaves as an elastic collision and thus allows a prediction of the ball's position to be calculated fairly easily. And it was very hard to find an aerial view of a cue ball hitting another one, so I simulated it with two balls of separate masses. And I plugged the tracker, and I then modeled it in Excel and got that the velocity went to 0 once it hit the object of the cue ball, and then the velocity of the stationary ball reached around 3 meters per second because it is lighter than that of the cue ball. So to model it, I chose the two balls in my system, with the cue ball being 0.17 kilograms, the number ball being 0.16 kilograms, and the initial velocity being -110, and with the initial velocity of the numbered ball being 0. And I used the law of conservation of momentum to predict the velocity of the numbered ball after collision. So mass of the cue ball times the initial velocity of the cue ball equals the mass of the numbered ball times the velocity of the final ball. And so the velocity of the final ball is equal to the mass of the cue ball times the initial velocity of the cue ball over the mass of the numbered ball. And to find the x and y positions, I just multiply them by cosine and sine of the angles, respectively. So if you take a look at the Python code, you can see the masses, the velocities, magnitude of velocities, F net, x and y velocities, positions updated with pos equals pos plus ball dot v times delta t. And then I used elastic collisions and did ball 2 dot v dot x equals ball 1 dot m dot vi times the cosine of the angle over ball dot mass, which is what I did before. And I'm going to run that. As you can see, it behaves very similar to that of the experimental results. So now I modeled. I want to see what it would look like if the collision were inelastic. So I would just change my equation a little bit, which I already did in my Python code. And I made a total momentum variable. Set that equal to ball's mass and velocity plus ball 2 mass and velocity. And then just edit these out. And ball dot velocity equals ball 2 dot velocity, which is total momentum over the total mass. See how that changes everything. I think they together with a slower speed than before, which makes sense. And that would look like if the collision were inelastic. And that concludes my video.